Hello, so today we are going to start with this problem called minimum number of days to make m buckets. And the problem says we get an integer array, a bloom day, an integer m, and then integer k. Okay, so what we have here is a bloom day array somehow, okay, which is an array, right? And then we have two integers, we have m and k, and we need to make m buckets, right? Okay, and to make like one bucket, we need k adjacent flowers. Okay, now the garden consists of, so garden has n flowers. The ith flower will bloom in, okay, ith flower will bloom on day, blooms on day, bloom day I, and then can be used in exactly one bucket. Okay, so only one bucket. Okay, now the goal here is minimum number of days to be able to make m buckets. Okay, so this is what we are looking to do, and if it's impossible, we can return -1. This definitely seems like a binary search, where with x buckets we can check if we can make them, right, with the current number, with the current, like basically the current config, right, or the current resources we have. And then from there we can say, okay, if we can we do a pattern here, so what would be our function here? So would we be, is it possible to make x buckets using n flowers that bloom with bloom day array, right? Bloom day array, right? Now if let's say we can make 3 buckets, right, with these bloom day, that means we had, this means we had k adjacent, we had k adjacent buckets that bloomed in day x1, like d1, and then we had, so we had 3 of these cases, and then day 2, day 1, or actually or before it, in day less than or equal to day 1, and then maybe these that bloomed in day less than or equal to day 2, and then less than or equal to day 3. That way we can make 3 buckets, right? And so if this is possible, then can we make 2 buckets with this configuration here, right? We definitely can, because we already have these 2, and we can make 1, and we can make 0 buckets. So the configuration is that it's true, and then when we reach a number that is too high, we get false, right? But what we are looking for is the minimum number of days we will need, right? And so here we can do that until we get the last true. Is it the last true though? So there is a problem here, because I don't need it in terms of x buckets. I need it in terms of days. So with basically here on day x, m buckets. Buckets is fixed. The configuration here is the day. To make m buckets, in day X, right? So if by day 3, let's say bouquets, M bouquets, if by day 3 we can make M bouquets, then that means we can't actually make them in day 2. But if we wait until day X plus 1, so it's not this actually. So if we can make, let's say, M bouquets in day 3, then we can make them in day 4, right? We can just wait an extra day. We can make them in day 4. So actually what we have here is, but we can't in day 2 because one of them may not have, okay, adjacent flowers may not have blossomed yet. So we have, our function actually goes f, false, 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 and then at some point, someday it becomes true, and we are looking for this first true, right? Okay, so now we need to kind of codify our function a little bit, but what is the range? What is the range that we are looking at? So the range is just the number of days we have, right? So the range is going to be, so from 1 of possible values to 10 to the power of 9. And so just to make, we can use a binary search on that range, and then this function we will need to write it. Is it possible to make M bouquet using N flowers that bloom on day X? So I would guess we would just, for day in 1 to X, maybe, we will see how many blossomed in this day, right? So day 7, this we have 2 bouquets, each would have 3 flowers. And so at day 7 here, we definitely have 3 that blossomed, so we can use these. So we can make 1 bouquet, and then we can make these not adjacent, so we'd have to wait. And so we will, at day 12, we will have all of them, and then we will need 12, right? Day 12, right? So here we have the bloom of the flowers, and we need 3 flowers, right? So we'll definitely need to check if we have 3 flowers. So maybe in the bloom day, we can count the adjacent day. So count adjacent bloom less or equal than X. So here this would count, basically we will give a D, so number of adjacent, we need 3 actually, so number of adjacent, so adjacent K, that basically adjacent K flowers that blossomed, that have bloom day K, bloom day of the flower, of course, equal to, less than or equal to D, right? And then here this would be like, this would be the bouquets that we have, right? And so this would give us, is it possible to use N flowers? So X is fixed actually, D is fixed. And so once we count this, we check, we return, basically f of X is the number of bouquets has to be bigger or equal to M, right? And how can we define this function here, count adjacent, for a day? So this function here, we will need to go through the blossomed, right, day. Actually, we just need to count the number of those that are equal to D. So let's say count equal to 0. And we of course have K here, we need K, which is the number we need, right? So while I is less than maybe the length of bloom day. And here we would check if bloom day of I is equal to, so maybe current count basically starts out as 0. If this is equal to or less than day, then we count it. We do current plus 1, right? Else, that means we check here if current is equal to k, then that means we found a bucket. So we do count plus 1. And of course, we initialize current to 0, or actually to 1 to account for the current, no, to 0 actually. And then we say, we do I plus 1 regardless, right? So basically we check if it's less than or equal, we count it as the current run. And then otherwise, that means it's not equal, it's too bigger, so we need to check before if we reach k. If we did, we count, otherwise we do current equal to 0, right? Okay, so I think this is kind of good. So let's first write our function here. And so we do buckets adjacent, and we check, we return if it's bigger or equal. And then we need this, of course, this function here. We don't need to actually pass k since it's available in that scope. So we advance this, and then we need to advance all of this. And then we need, of course, I equal to 0 count. So all these values would be 0 initially. Okay. Okay. Count plus 1, count equal to k, count plus 1, cool. And then at the end, we just need to return how many we got, how many buckets we got. And then here we need to start our binary search. And so our binary search, we need to do the usual template. We need to go outside the range because these will never be called. So basically the range is 1 to this. So this is the range we are dealing with. So we need outside the range, so 0, and then this plus 1. Okay. And then we will do our loop here. Low, high minus 1. We need mid. Which is low plus high divided by 2. And then we check if f of mid, that means we want to go through here or here, we want to go left. We want to maintain the property that f of low is always false, and then f of high is always true. And so what this would mean here, f of high is always true, would mean to here f of mid, so it means high is equal to mid. We need to maintain that property. Otherwise, we need to say low equal to mid, and then we need to return the true value, which is high. Unless, of course, we didn't find anything. So if we need to do one check, if high, then this is true, so we need to return high. Otherwise, we need to return minus 1. This is the day, so it's x actually. Okay, looks like that didn't work. Let's see, where did we have problem here? High minus low less than 1 actually. I think this is the bigger than 1. Yep, this is while it's bigger than 1. This is what we're trying to find. While there is a difference of just 1, so we want to detect when they meet. So when the difference between the two is bigger, so we'll keep going until the difference is just 1. So that's what we do there. Now let's see if our function is correct here. So cb say print for maybe x days. Can we make bouquets is that would be just the value, this value here. Okay, it seems like it didn't go down by a lot. So it seems like it kept saying false, and so something seems wrong here. So what we can just make this f instead. Okay. And then here this would be bigger or equal to m. This is what we are looking for. The m buckets that we have, and we are looking for k. So here we are actually, even if it's bigger, we do want that, right? So here we want to do as well here plus current divided by k, because if we can make 2, then that's great. So okay, let's see here. Let's try here. So what if we had 7 and then we divided by, let's say k here is 2, right? So can we get 3 out of this? We want k is the number of adjacent one, we just need 2, so we would get 1 1 2. So 2 4 6 7, right? So we can make 3. So that's accurate. Okay. So let's see this. Let's say here. So this is the number of buckets. Equal to this. So bigger or equal here, and then we can print it like this. So for x here is middays. Okay, we can make. Can we make m buckets? So here we can have buckets, and so we can do this. So can have 0. That doesn't make sense. For this amount of days, that doesn't make sense. So there is a problem here. With current equal to current. Okay. let's see here, in end with count equal to that, and count equal to count. Interesting. Yep. So the problem here is if current is bigger than 0, we need to add it. If we end because there was a run, then we need to add it differently. Okay, so that seems to have worked. Cool. Let's, okay, let's start these prints. Okay, so that case works. Let's try with this case with this array, and we have 2 and 3. So this should give us 12. Okay, that didn't work because the output is too high, so it must be that, yep, so if now returns a value, so I need to look at this actually. Okay, and then we need this 1 1, then this 4 2. Okay, so this should work now, I think. Let's submit. Cool. So that works. That works. Cool. So again, let's just clarify this a little bit one more time. So we just check for X days if it's possible to make M bouquets using, for day X, if it's possible to make M bouquets using N flowers. And then we have this property that this function is like has this property, it stays false, and then once it reaches true, it keeps being true, because once they blossom, you could day after you can still use them because they blossomed, right? So we have this property, and we are looking just for the first true. So we just go through the range of possible days, and we try to find the minimum one that is true, and that's pretty much it. Yeah, I think this is good. Thanks for watching, and see you on the next one. Bye.